Yes. Hey, welcome back. Now let's solve the question diagonal sum in a binary tree. And again, if you remember from very long ago, I am telling only one thing: learn vertical order traversal, learn vertical order traversal, because that is very important to you to traverse the tree. And again, this is another variation of vertical order traversal itself. Just by looking at it, it might not seem like that, but yeah, believe me when I tell this is nothing but a vertical order traversal itself, but with very minor modification. So let me first go over what we do in vertical order traversal. The lines will be same, but how the vertical order traversal will go, there will be a line like this, and it will split 9 as the first leftmost index, and then you'll have 2, 10, 11 at the same place. You will have 1, 6, 4, and 12 at the same place. You'll have 3, 7, and 5. Yeah, that's how the vertical order traversal goes. And this is like 90% the same of vertical order traversal. But in vertical order traversal, what we did is that we had a straight line. But how will you convert a straight to a diagonal line? Yeah, again, it's not a very big thing. What you can do is just, how do you tell? Rather than adding or subtracting a level, like what we'll do is in vertical order traversal, as we move to the left, we subtracted the level, and as we move to the right, we added the level. But how do you change the angle of that? It is very simple. To change the angle from 90 to 45 degrees, we just have to not add or subtract. That's all. Either we should not do the adding part or the subtracting part, and depending on how we did that, the what do you tell the angle will change. So, for example, over here, since we have to go to the left, like we have to move from this is the first level, second level, third level. So we are moving from right to left. So we should not add the level. We should just subtract the level. As the level goes, we should just subtract. But if we never add, but just subtract, then what will happen is that the level at the right will never change. So as soon as you put one, for the left level, for node 2, you will subtract the level. So 2 will be at minus 2 level. But for the right, you're not adding the level. So 3 will still be in level 0. And again, for 3, if you consider, for going left, you're subtracting the level. So 4 will be in actually the level of 3, which is 0 minus 1. So 4 will be minus 1. But 5 will still be in level 0 itself. Why? Because you are not adding the level. In other words, for the level, you are not adding the value of 1. So 5 will still be in level 0 itself. Yeah, that's all it. That's very simple. As soon as you know that part, it is very easy to do. So let's import the important things. Where is default and DQ present? Collection. And again, you have root and you have the level which is currently 0. And mapping to the default dictionary of type list. And then let me just remove this. Yeah. While q exists. Yeah. So again, if you remember what I told, no dot, but let me just finish the what you call placeholder code. Again, there is nothing much to do. For going left, you are actually subtracting the level. But when you are going to the right, you are not touching the level. And again, so what we'll do? Mappings, mappings at the position level. For that, we'll append the value of node dot data. Yeah, believe me when I tell this is all it. Yeah, very minor modification to the actual what you call a level of reference. And yeah, let me just return some dummy value and let me print mappings. Okay, I forgot to add another bracket over here. Yeah, this is not a very good example. Yeah, if you add 4 and 3, you will get 7. If you add 1 and 3, you will get 4. Let's write a bigger tree. Yeah, I think this is the tree which is given over here. So let's just compile and run this. Yeah, if you see at the level 0, you have 135. At the level -1, you have 2, 4, 6, 7. At the level 3, -2, you have 9, 10, 11, 12. That is what is expected. So that is what you wanted. So now what we'll do is I just did the list to show you the actual level. So I can just directly do in. And rather than appending, I'll just add the value over here. Yeah. And now if you see the mappings, what will happen is that you will actually have the entire answer itself, but it will just be in the form of level, as you see. And we can directly return the, what do you call, values. So what we can do, I will return mappings at the position key for key in. Yeah, this is it, I think. We just compile and run it. I don't think we have to solve the keys, but if it is required, yeah, I'll just submit it once and then check it out. Like if it wants me to, yeah, I it request me to sort the keys. So mappings dot keys, and we want to sort it in reverse order. Let me just submit it now. Yeah, as you see, it works. So why should I sort the keys? Yeah, let us take this input. Yeah, it would be better if we could get some better input. Yeah, one. I'll just modify this null two, and then two will have null, and then three. Yeah, I'm unable to reproduce this thing, but believe me when I tell you have to sort it because since it starts from 0, -1, -2, when you have some, yeah, for some conditions it will not work, so you have to sort it. Let me not go into the nitty gritty of it. But yeah, that's all for it, and thank you for watching, and goodbye.